Hello, my name is Melanie Coulter, and this is my presentation for Lab 3. In this lab, I will be using GlowScript code to simulate the trajectory of a star that is orbiting a black hole. The goal is for me to be able to determine the mass of the black hole. In order to find the mass of the black hole, I will need to find the net force on the star. And we will be using Newton's second law and the gravitation law in this lab. For curved motion, the rate of change of momentum can be broken down into parallel and perpendicular components. And the same can be said for the net force. The net force is equal to the change of momentum over the change in time. You can see it broken down on this slide. Now here's the code for my simulation in GlowScript. First, I changed the mass of the star to be what the assignment called for, and then next I changed my delta t to be the number of seconds in a day. I then defined P initial and P final using the momentum principle on lines 166 and 167. I defined delta P and delta V next, and then changed the net force to be dP dt because of Newton's second law. As I stated before, we have to break down the net force into parallel and perpendicular components. The next few lines are a reflection of that. And finally, on line 195, I define the mass of the black hole by rearranging Newton's law of gravitation. Here's my code, and at the bottom you can see how I configured my force arrows, and now I will run the simulation. As you observe the trajectory in motion, notice the force arrows which are growing and shrinking at different points. The orange arrow represents the net force and generally points towards the black hole. The pink arrow represents the parallel force which points in the direction of the velocity and the momentum. And the blue arrow represents the perpendicular force, which always points toward the center of the circle or perpendicular to the velocity. The arrows appear to get smaller as the star moves further away from the black hole. And this makes sense because of Newton's law of gravitation. The average mass of the black hole that I gathered from the GlowScript data came out to be 8.55 times 10 to the 33 kilograms. Now, let's discuss more about the parallel and perpendicular components of the net force and how those are different than the change of momentum and its components. We can't actually calculate the magnitude of the net force, but we know the star's position at every day of the year, so we can calculate the change of momentum. Now, let's imagine that the black hole I've been working with is replaced with a different black hole in the same location. We will also assume that the trajectory of the star does not change. Would we be able to tell the difference between two black holes and find the mass of a new one? The answer is no. The trajectory does not change, so we know the mass of the black hole does not change, based on gravitational law. For example, if our sun was replaced by a black hole, the Earth would continue to orbit like normal, and it wouldn't be great for us humans, but the Earth's orbit would not change because the mass of the black hole would be equal to the mass of the sun. Thank you for watching.